they say that 3-point charges are located on the x-axis at the following positions. Q sub 1, which is equal to 2 microcoulombs, is at x equals 1 meter. Q sub 2, which is also equal to 3 microcoulombs, positive 3 microcoulombs, is at x equals 0.0, so at the origin. And Q sub 3, which is equal to minus 5.0, which is equal to minus 5.0 microcoulombs, is at x equals negative 1.0 meter. So they say, what is the magnitude of the electric force on Q sub 2? Then here we have to use the superposition principle. What is the magnitude of the electric force at Q sub 2? Magnitude of the electric force at Q sub 2. So the first we have to do is to locate those charges on the coordinate system. And what they say, we say that we have this charge of 2 microcoulombs at 1 meter. This one, that is Q sub 1, and is 2.00 microcoulomb, is at 1 meter from the origin. We have Q sub 2 at the exact origin. That is 3 microcoulombs. And we have Q sub 3 in the other side, and it's negative, right? And will be here. It's negative, and will be at negative 1 meter, so to the left of the origin. So why to the left? Because they say negative 1 meter. Negative 1 meter is to the left of the origin. When they say that this one is at positive 1 meter, this is to the right of the origin. This one is left of origin because it's negative. And this one is a charge of minus 5 microcoulombs. Now, this distance is 1 meter. And this distance is 1 meter also. Right? Now, what is the force that the charge Q3 hertz on Q2. The force that Q3 hertz on Q2 is a force of attraction. So in this direction we have the force that 3 hertz on 2 is an attractive force. Now between Q sub 1 and Q sub 2, the force is a force of repulsion, right? It's a force of repulsion. So this one will be the force that Q sub 1 hertz on Q sub 2. That is the force that 1 hertz on 2. So this one is the force that 1 hertz on 2. And it's a force of repulsion. They are repelling each other. And this other is the force that 3 hertz on 2. And it's a force that 3 hertz on 2. And it's a force of attraction. So at the end, when you analyze the forces that are on Q2, you have a force that 1 hertz on 2, and you also have in that same direction the force that 3 hertz on 2. So the resultant force will be the addition of these two forces, right? But now we need to calculate those forces. So force that 1 hertz on 2 would be K Q1 Q2 over the distance from 1 to 2. So that force from 1 to 2. So that force is 8.99 times 10 to the 9 newtons meter square per Coulomb square times Q sub 1. Let me just better put this optimize the space. So this is 8.99 times 10 to the 9 newtons meter square per Coulomb square times, now Q sub 1, 2 microcoulombs, no? So it's 2.00 times 10 to the negative 6 coulombs times Q sub 2, 3 microcoulombs, right? So it's 3.00 times 10 to the negative 6 coulombs. All this divided by the distance from 1 to 2, 1 meter. So when we calculate that force, of course, the meters square are going to cancel with this meters square, the coulombs square are going to cancel with this Coulomb square, and what we're going to get an output is just newtons. When we calculate that force, that is the force on 2 due to 1, or that 1 hertz on 2 is 53.94. So let's say 53.9 times 10 to the negative 3 newtons. In what direction? To the left. To the left. Now, we calculate now the force that 3 hertz on 2. And then now we have to change the charges and we have to change the distance. So this force would be K times Q sub 2 times q sub 3 over the distance from 2 to 3. Now, the distance from 2 to 3 and the distance from 1 to 2 is the same. The distance from 2 to 3 and the distance from 1 to 2 is exactly the same distance. So, basically different here, the magnitude of the charges. So we have 8.99 times 10 to the 9 newtons meter square per Coulomb square times q sub 2, 3.00 times 10 to the negative 6 coulombs times q sub 3, 5. I will just put the value, the absolute value, 5 times 10 to the negative 6 coulombs. All this divided by the distance, that is 1 meter squared. When we calculate the magnitude of this force, this magnitude will be 189.0, 189 will be basically 189, approximately 100, we have 188.8. 188.8 times 10 to the negative 3 newtons, also to the left. Also to the left. No, sorry, come on, I just gave you the value of the resultant force. I'm looking at the wrong place. So this would be 134.85. This value is 134.85, so 0.9 times 10 to the negative 3 newtons to the left. So now we know these force, the 1 hertz on 2, and we know the force, the 3 hertz on 2. Now we know that both forces are in the same direction. So we know that the net force, we can call now this force resultant force, or net force, will be the force that 1 hertz on 2 plus the force that 3 hertz on 2. So it will be 53.9 times 10 to the negative 3 newtons plus 134.9 times 10 to the negative 3 newtons. And we're going to have that resultant force would be 188.8 times 10 to the negative 3 newtons. 188.8 times 10 to the negative 3 newtons. In what direction? To the left. To the left. Now, if you want to express that force, not in scientific notation, but in decimal notation, this is the same. That's 0.189 newtons to the left.